Okay, okay, let's start this gig up. Hey everyone, let me know if you can see me, if you can hear me. I can see there's a few people joining. As per usual, just a quick sound check so I know that everything is all right. I'm not just waffling in silence or being muted, or perhaps you cannot even see the actual stream. So do let me know if it's coming through, if you can hear me, if you can see me. Leave a comment in the chat. And we're very slowly going to start today's topic, which we have so much to cover. So many different themes and signals, and very interesting ones at that too. But leave a comment in the chat so I can. Okay, I got one from Alien. Let's go. So I guess you can see me, you can hear me, right? All good. Okay, okay. Let me see if I can adjust a few things before we kick off. And I know that some people are gonna join in as we just warm up too. All right. Okay. Cool. I think we're ready to roll. Right. So as people drop by, I'm gonna just kind of preface and intro a bit of the thinking, I guess, behind this session, because you might question like why this matters, or like why should you care as a UX designer, product designer, strategist. Maybe you are a PM or an engineer. Maybe you're just keen to understand how to build better human experiences or user experience. It could be customer experience. It could be anything, basically. Why would such a deep tech matter so much? Or why should you get started with it? Well, reality is that BCIs, or brain computer interfaces, and I think Neuralink recently labeled a term BMIS, which is brain machine interfaces. Doesn't really matter. It's just a different label for the same thing, given, granted, it's a bit more maybe advanced than it used to be. But it matters because it's been around us for a good 100 years or so. And I'm going to cover a bit of that history and kind of gloss over it. But it's good to understand that it's a technology which has been developing for so long, and it's been around us and actually saving lives in, health tech and healthcare generally. It's kind of like becoming much more than that right now. There's different use cases, there's different applications, and this is exactly what we're going to explore today. As you can see on my whiteboard, I have a lot of themes, and all of them really to visualize exactly the thinking and to prepare you a bit for what's to come with the BCIs. Because I think in the next 5 years, maybe, I'm sure that someone who's watching this is gonna be working or having their fingers in the BCIs, because it's gonna happen that it's gonna just become much more commercial and much more widespread and available to more people. Okay, so now that I got that out of the way, let's start. And do let me know in the comments by way as I go. I like to hear your thoughts. I like you to challenge me too. I like you to comment as usual. Let's just have it a bit of exchange. So it's not just me unloading a lot of different insights. All right. So what is BCI? You might have heard that. Just think about this as if it's like brand new to you. It's what Elon Musk and Neuralink have been doing most recently. You might see in the news and the tech updates. But ultimately, there is an implant in between a few actors. One is the user, and this is obviously oversimplifying. And another big actor is AI, or simpler tech stack. And again, implant is just one way. It's the invasive way to actually, establish the BCI, or that brain computer interaction between the user and AI, or a simple tech stack. Now, there are non-invasive BCIs too, which we're going to cover, but just so you know exactly what the exchange is like, it's not just the user, it's not just the implant, it's not just the tech or AI, it's the combination of those three, which is super important for that interaction to happen. And interaction could be limited to just reading information, which could be, let's say, electromagnetic, the EEGs, let's say, or magnetic resonance type of machines, which just read what's happening in your brain. But if we apply a stack of AI to it, which I'm going to cover too, you're going to basically expand the scope and you're going to increase that interaction because the users are able then to do something about it or be able to interact with the actual AI and exchange information, not just kind of like process it in their heads, so to speak. Now, the examples of them. And I think this is what I'm hinting at. Let me just see if I'm actually putting it on a screen so you can see and I don't crop anything out. All right, this should kind of cover it. So there are 3 different types of BCIs around us, or BMIs now, like it depends how you skin it. But again, there's non-invasive, which you might have been privy to, or maybe from your family, someone actually experienced some of it in, let's say, in medical settings, let's say in a hospital. You might have had EEG performed on you. Like, for example, I did a few months ago, had the EEGs and didn't even think that, okay, this is actually a BCI or brain-computer interface in any means. To me, it was just like a checkup, basically. It could be that you maybe used the MEG or MRI, which is even more common. You probably heard about MRI or maybe seen on some sort of TV show what MRI is. So those are non-invasive because we literally apply some sort of machine or some sort of electrodes to head, use some sort of other, basically machinery to process the information and then tells you some sort of story if you're a doctor or if you're a practitioner. And of course, it in the end tells you as a maybe patient a story of what's going on with you or, if you have any conditions, for example. So this is very prominent really in medicine. Now, in the middle of that, obviously between that invasive or all the implants, there is this partially invasive element, which is the ECOGs, let's say. And ECOGs are quite common in, let's say, scenarios of, and again, I'm not an expert in this, by the way, so I might get a lot of things wrong in this live stream, but I'm coming from more of a UX designer, as a practitioner, as a strategist perspective. So I'm going to gloss over a lot of the elements, but I'm going to try to download as much as you should know, or as much as you should kind of like prepare for if you're ever going to get into that BCI design. But ECOGs or ECOGs basically are used in these situations where you have, let's say, an opening to the brain and you have to stimulate the specific areas of the brain in situ. So there are some sort of segments, there are some sort of areas of the brain which you know where to apply, electrodes or some sort of other some sort of other interventions so that you can get some, motor control response or some sort of other responses. But that's in situ. It's basically, obviously as a user, as a person who is within that scenario, you wouldn't be able to go on with your day, through the electrocorticography or the ECOGs and basically just live with it. It's obviously in situ for that specific surgical procedure, let's say. And then topping that up, there is obviously that invasive area, which is all those different things. For example, you might have heard about single unit or multi-unit BCIs, and that was just basically affecting specific areas, let's say singular neurons, or let's say bigger batches of neurons in your brain or, someone else's brain. There's the visual cortex implants. There's a lot of different implants actually, which could be part of your brain or could be basically implanted in someone's brain for them to do something. But not all of them are BCIs because the BCIs basically, and I might get this definition wrong, but BCIs are quite limited to brain and how brain is basically observed and what sort of signals are being detected and how it's expressed in a motor control or some sort of tech stack control. If it involves nerves or if it involves some sort of muscles or things of that nature, which is also super common, it no longer is a BCI. It could be prosthetics, let's say, and you are controlling some sort of prosthesis, or even if it's, I don't even know what it could be, let's say, auditory things, let's say, or something along those lines. It might not be classified as BCI, but who cares? Ultimately, it's just for your understanding, so you know. Now, the last one is, and of course, there's more categories here. The last one is microelectrode arrays, which is basically a combination of a single unit or multi-unit BCIs, and one of the startups, BrainGate, which is actually a challenger or maybe the other way around. The Neuralink is a challenger for the BrainGate. Use the micro electrode arrays, as you see it here, to basically implant the BCI in someone's brain, and then give them some sort of experience. And obviously a person was in limited mobility, quadriplegic, and all the different factors were considered. But why I'm showing you this is that for you to understand that the BCI starts with very non-invasive things, which you could apply with the headphones even, which I'm going to show you an example of in a bit, but also could be, let's say, just in a simple doctor's appointment where your information is read or interpreted from, let's say, MRI. And of course, it could be partially or very invasive. And obviously, as I'm hinting here, the risk and the use cases, so to speak, or ability to observe those use cases increases drastically as you go through this. So the more invasive, obviously, the bigger the risk for the actual user, the bigger the risk for the actual product. If you think about product, the bigger the risk for, let's say, just generally of success of a solution and it actually being applicable to someone's scenarios or actual people being able to achieve what we need to achieve in whatever capacity or in whatever use case. And then obviously the multimodality of the actual interaction. So right now, the more invasive the procedures or the more invasive the BCIs, the more basically capable the people are to do something extra. And obviously that could vary in different fields. Cool. Now, how does it work? And this is going to be a very quick run through again. It's a 101 summary, so do make sure to invest some time to research these things. If it sounds like very interesting, or if you find something which would kind of like, okay, this is something I need to look into, do that. Do follow up. I added a few links so you can screenshots here, or you can kind of progress with that and go for it. But the basic kind of schema, I guess, of a brain-computer interface can be summarized as this. A person who, let's say, might have non-invasive sensor of sorts, some sort of hardware, is able to, well, I guess is stimulated with some sort of feedback first and foremost, because the feedback is always there, right? Like a person, if they would just put on something that would maybe be flat in terms of what their EEG is telling as a device here. And EEG is probably the most common type for non-invasive brain-computer interfaces right now. If you ask me, let's say, all the startups are really looking into it. But the actual device, the actual signals are being acquired through that device. So they're basically using the electromagnetic waves, a lot of different frequencies specific to it. So let's say if I would compare, and this might be a bit technical, but it doesn't matter. I think you kind of need to know EEG or MEG or MRIs. There's very different technologies used for that. For example, one is magnetic, one is really just electromagnetic waves. And the frequencies and everything else are very different. Of course, you don't need to dig deep into that if you don't want to know. But at the basis of it, the actual signals should be acquired by the technologies for you to do something with that. And it goes in this loop of signal processing. And this is how a basic AI could work, or a basic tech stack could work. But basically, you digitize those impulses or those signals, you extract some sort of features as a third step, and then you classify it. So like, what does that actually mean? Because a lot of the different, inputs or a lot of different ways are actually not that useful. You kind of need to know exactly what is what. And as such, in a lot of the EEGs and a lot of the examples you might find on the internet, and I'm going to show you, here in this schema, you might see, okay, it starts with the user, but they usually are stimulated with something, because you have to show, I don't know, it could be, a monkey who's a subject and they're presented with a square or some sort of color or some sort of other bits which we recognize, and then that signal or that spike is being detected and classified. So the feedback, the awareness of affordances, all those UX principles start here. It's like immediately, if you are, I don't know, when you work in UX, you know exactly what this means, because it has to be an equal exchange, and you have to be basically stimulated as a user to then for you to produce some sort of brainwaves or some sort of other changes in like, in EEG or magnetic resonance, and then that can be captured. And obviously, the technology here, for example, which could be AI, could basically produce some sort of output, and then that goes in a circle to feedback to the user through some sort of apps. Now, applying the apps here is, in this schema, it's kind of just one box. But within that, you could apply the generative AI, you could apply the machine learning, you could apply the predictive and assistive algorithms, basically. You could give some sort of continuous feedback to the user, and you could learn from the historic data. So the more the actual users use your BCI, the more you can learn about their behaviors, the more you can learn about what their preferences are and what does actually mean what. And this is what Neuralink did really well, which again, I'm foreshadowing, but we're going to jump into it because it's very interesting of how they approach the user experience when they implanted a first human test subject, and what happened next, because they used a lot of again, historical data, Bayesian methods of learning, and structured signals being converted into more structured data, and then also giving them the apps to play with, to calibrate the BCI and so forth. So there's so much of opportunity and actually so many touch points which a designer like yourself would have to design for. Because again, a question could be from someone who's watching, hey, why would I care? Like, I just want to design mobile apps. But you should, because those mobile apps are going to be part of a BCI journey or flow. It's just unavoidable. There's going to be so many different products and features required for these experiences to be good, because there's, again, onboarding, calibration, learning, and then phasing out, because again, even if it's very invasive, it's not yet invasive enough or at a good state where you could, let's say, implant something and it's going to stay in your body for the rest of your life. It works with some medical devices, but not necessarily with BCIs, because of all the other hardware, quote unquote, malfunctions, and us as humans having limitations. So that's the intro. Let me see what the actual chat, Adriana. Hey, what are the ethical concerns associated with brain-computer interfaces? Are there any laws or regulations that control how BCIs can be used? So there is, but it kind of again, this is, at the surface level, a lot of those, a lot of the testing or a lot of the trials go through animal testing, and then, let's say in the US, you have FDA approvals. That's, common thing, and only then you can go to human trials. From what I could see, and this is again very surface level, at every single step, because these are years of actual development. Again, the actual BCIs took us 100 years or so to get to where we're at now. Like, literally, it started in 1924, so literally 100 years, right? Until the Neuralink. And there's very interesting developments, but this technology is not new. It's just that it in, let's say, it's first being applied in actual healthcare. That's where the ethics would come in mostly, because you have to get your patient consent, you have to develop those, there has to be a lot of trials and obviously fixing of the errors. But if you're very interested, I would just advise to look into the FDA approvals for BCIs. There's so many studies, so much research done, because all of the BCI right now is research. And obviously the practical outcomes and the fruit, so to speak, of the labor are mostly mostly outputted in the medicine or medical fields, again, for MRIs and things of that nature. But really good question. I think very important question, because then I'm going to show you the demos, which you might seen online before. It's you're going to see exactly what the person did, what their respective feedback is, how they perceived it, how they experienced a BCI implantation, and what we actually think about it, because we had to sign. I don't know if we're going to cover it all. Again, I shared a podcast on a community, so you can look at it. But the actual person, the actual procedure took 6 hours, I think, and I might be wrong by way of numericals here, but just bear with me. The actual trial or getting to that took weeks, but then after that there's weeks. But there's basically even the people who are implanted with that, they are researchers themselves. The person who's got the Neuralink, I'm gonna get his name wrong, but it was Nolan, I think his name is. They are literally spending daily, and they're engaging with the actual Neuralink team daily, on a daily basis. So they're part of a research team. So there is so much involvement and so much back and forth. It's not like you're getting something implanted and you sign some sort of TNCs and you're left off. No, this is a process which is going to persist for decades, basically. So we're never yet going to have kind of like, ethical concerns and mass which we would have, let's say, with generative AI escaping into, because it's very big stakes here, very big risk, and that has to be controlled for. Would this technology replace XR? Oh, you're jumping ahead, Alien. So it's not going to replace XR, but it's if you converge the two, this is where the magic is going to happen. And I have a segment for that too. So, just bear with me, because I think there's a few bits which are quite important to call out. So first one which I wanted to really quickly go through is the typical journey, and what the typical journey would be like, for example, for a user. And I'm going to compare two specific branches. One would be motor control, which each of us, or maybe someone watching this video has a BCI already. So, they could correct me. But most of the people right now use a motor control. And a person who has the BCI implant or non-invasive technology applied, they would have a BCI control. So if we would compare the two, let's say, in every action, and this is my, as a UX researcher, observations. Of course, it could be more nuanced, more specific, but let's just bear with that. For every action, you, as a user, as a human, you plan to do something, you think about it, you execute it, and then you observe as a last bit, basically. The steps could be, and imagine if a scenario is that you work at a desk and you decide to listen to the music. You might use a lot of interfaces. You might use a desk, you might use a mouse, you might use a keyboard, you might use the OS kernel and GUI, or what you see on a screen. To summarize it bluntly, you might use some sort of apps or app X, or you might use a screen, a table, maybe even a mug. It's an interface. Like everything is a product with an interface, basically. And there is literally thousands of touch points around you at any given point, even as you watch this video. But let's just presume that the person with motor control decides to listen to the music. They look at the screen because they want to execute that space, and they look for, let's say, something like Spotify launcher. You basically have to look for it. Then their hand with a mouse moves on that trigger, which is another second of some sort of action. It could be quicker, but basically if we split those steps, it would look like that. Then we would click on that trigger to unminimize, let's say, a Spotify app or open it. Then we would look for a trigger to resume playing the music, and that's the simplest journey. Then we would move a hand with a mouse on the trigger to play it, and then we would click a trigger to play the actual music. So there's micro steps involved, or the steps to the actual journey, which requires both of your motor control with your peripherals, technology, but also arms or hands, but also your visual cortex and your brain and everything involved, even your spinal cord and everything in between, and musculature. Literally hundreds or thousands of different systems are involved to make a simple execution and a simple playing of the music happen. Now, once that's done and we click the trigger, we see the toggle for playing happen. So, you notice that instead of pause, it goes to played, or vice versa. So you can see that you can pause the music, and then we hear through our auditory sensors that the music is playing. So this is a long journey of us and a simple journey at that playing the music. Now, with a BCI, that would look slightly different. So again, you would still have all the different interfaces, right? Like you might have limitations of them. Maybe it's very different, depends who you are. Maybe you are, let's say, if we take Nolans with Neuralink example, they're quadriplegic, right? So they're disabled neck down, right? So they have, a specific chair. We have other devices to support the movements or signaling or, communication. There is a lot of other bits, maybe a bed, maybe something else. Basically, their interfaces expand. And if they have Neuralink enabled, we also have apps, which I'm going to show, and we have their laptop. We have basically many more devices around them. The challenge here is going to be a simplification as well. If, let's say, you're a designer in a BCI field, you're going to need to consider exactly how to simplify all of that and who is your user. Because to make it accessible, you're going to need to expand the systems and the touch points. But to make it good, you're also going to need to simplify and so forth. So there's going to be a balancing act between the affordances and feedback and the interaction touch points. And then the even bigger challenge is going to be how to make it more commercial so absolutely anyone could use it. Anyhow, but the journey would be still the same. You would plan, you execute, and then you observe. The steps, though, would be different. You work at the desk, let's say, or maybe in your bed, decide to listen to the music. You look at the screen and find a trigger, e.g. Spotify launcher. And that's where your moving of the hand would be replaced with thinking about navigating to it. And as such, there is immediate exchange with AI, which analyzes, compares with the historical data, and then actions the actual move on a screen. Then you think about clicking the actual touch point, because you're going to see from devices. I'm basing a lot of this journey, by the way, on that Neuralink demos, but you have to basically navigate just like you would with just like you would your cursor, but minus a motor control. So you would think about it again. AI analyzes and actions it. You look to trigger the resume button to play the music. Again, you think about it to navigate to it. You think about clicking it, and meanwhile, the AI analyzes the actual signals, processes it, and acts on it. But with AI, obviously, as I shown the schema before, you have pre-processing, feature extraction, classification, signal output, but AI is able to overlap that with what you did before for, let's say, months to come to it. Because you're going to need to learn how to use the BCI as a user. You're also going to need to understand exactly how big is the spike, what does that mean. You're going to need to adjust different things. Again, a lot of different variables to consider, but to compare the actual journeys, a lot of that motor control is simply replaced by thinking, and a lot of that thinking is tied in to technology stack or AI of any sort, machine learning. So other things which I wanted just to quickly call out to compare between the journeys is, interestingly, that, and again, this is limited research, so do your own research, please do so. Don't take this as a gospel. This is as much as I could quickly pull out of interesting themes, but the theme of the fastest possible conscious human reactions are around 0.15 seconds, but most are around 0.2 seconds. Unconscious or reflex actions are much faster, around 0.08 seconds, because the signal doesn't have to be your brain. And this is just for you, again, if I would oversimplify it, thinking about doing something. It's reacting to the feedback. So if you see some sort of, I don't know, Spotify song come up and you want to change it, that's the time it takes you to actually react. And then, as you do those motor actions, there is latency, because you have to move your arm with your mouse to a different area. You have to, again, correspond to the cursor as it goes. So you see where there's so many different seconds involved of that journey to actually understand how to, again, make it more efficient or increase the efficacy on it. And then obviously there's a mouse latency, because you could see the cursor drag. There is a screen latency, let's say 4ms, or maybe it's a 30 hertz or 60 hertz or 120 hertz monitor. Therefore, you would see a drag, you would respond as well. You would have a lot of basically thinking and processing in your brain to do so, as we do every day. And then, of course, other things to consider. So the actual extent, and this is human-computer interaction 101, by the way, but the actual extent from us observing some sort of feedback and actioning it through motor controls is such a big taxing and such a very specific kind of like requirement for any human being already. And why I'm bringing this up, because it takes so much time. So let's say for me to change the tune or to change the music, it could take 1 second maybe of combined motor plus perceptive time, like the latency. But if I would, for example, want to resume the music, it probably would take 2 or 3 seconds even. So it's a massive amount of time. Versus what happens with the actual Neuralink. And I pulled this up just to show you and get some anecdotes because it's very interesting podcast. Again, check it out. It's just gonna kind of blow your mind of what exactly is happening behind the scenes with the patients who actually use Neuralink. Because the quote I extracted is that it sometimes moves before I even think it to move, which is massive. Means that between actually, let's say if we take a random one around 0.2 seconds measure, that's what it would be normally, right? But with a Neuralink, the statement, and this is anecdotal follow-up, obviously, but it says that it would take less. So maybe it's 0.1, maybe half a time or something. So it moves way quicker than the person would be like, oh yeah, I should click this. It kind of like immediately is based on, again, AI, subconscious signaling, conscious signaling, and a lot of other deep tech involved. And let me just quickly play this because I think it's gonna be pretty good for everyone
How cool
to
was it the
know.
first day
Do let me know if you can
to be
hear
able to
it.
play video games?
Yeah, it was awesome. It was
What
really,
did you
really
play?
cool. Civilization 6. I don't know. I don't know if you've heard of it. It's a massive game. It's something I've been wanting to play for a long time. I was able to kind of sort of play it with
Of course, I paused
How
it.
cool was it?
assistive technology over the last few years, but not really. And I played it like all night. I didn't sleep. It was freaking awesome. Man, I just love. I mean, I grew up being a gamer. I grew up in kind of this age. So the last 8 years, I've watched all of my friends play games that I really
Wow.
hope so. Yeah, that would be
So you'll
sick.
be able to play shooters like Call of Duty.
Yeah, yeah. That brings up another thing. Like, I basically have an aimbot in my head. So yeah, so
Oh, that's
That's a big one.
they'll
crazy.
probably have like different leagues for people like me because it's just not fair. Um,
Wow. Is it that accurate?
it's that accurate, and it's
Wow.
faster. One thing that I found with the Neuralink is something that kind of blew my mind too. Is that when I'm attempting to do stuff sometimes, or I'm thinking it to like move in a certain place, sometimes it's so good that it's moving before I even like think it to move. It's almost like if you think about moving your hand, the signal is basically already being sent before you move your hand. Like your mind is saying, okay, he's about to move his hand, basically. So the signal needs to be sent all the way down and back up in order for you to move your hand. So the speed that all of that happens, and it's almost a little preemptive. I saw that with the Neuralink, where it was moving the cursor before I was actually moving my hand.
And this is massive. Like you can hear again. I can tell you one story, but you can immediately hear the anecdotes from the actual user. And let's just put our user testing, user research hats. But to hear that is amazing because the user themselves perceive that okay, for me normally, and of course this person was capable, like fully abled basically before they had an accident and became quadriplegic. So they know exactly what comparison is between them using the motor control and using their minds to actually perceive feedback and act on it versus the actual Neuralink, which is instant or quicker even than they think about doing it. So like they have inclination and immediately it goes with it. I mean, it's amazing. It's absolutely like amazing. And obviously, they are joking about gaming as one of the use cases where that would come in place because you can obviously have like an aimbot and outperform ultimately any other person who doesn't have that type of technology in place, which is amazing. And I'm not going to bore you with the technicalities, but the data, the actual compression of the data between Neuralink and AI, and the actual chip, which is part of the Neuralink, because the Neuralink chip is implanted together with the actual technology. It's very fascinating how much processing goes into it and how it's charged and everything in between. It's a very technical thing, but make sure to look into it because I'm not gonna just unpack and do the promotion for them or the ad. But it's fascinating how much thinking went into it for something like that happen. It's quite magical. Alien is asking, how will BCI differentiate between you just thinking about listening to music and wanting to listen to music? Amazing. Again, you're foreshadowing my points, which are going to come, but the actual user has to train it. As I mentioned before, Nolan, a person who's actually has the first Neuralink, they had to spend months using it for AI to adapt and know exactly what Nolan wants to do. And that's the beauty of AI and where it has the most value. And I cannot just freaking like overemphasize this enough. That's where the actual use cases are, where you have so many unstructured signals of me wanting to do X, Y, Z, and then doing it over time with a pool of historical data of millions of failed or successful answers or things which I want to do. And then in the end, AI learning, okay, this is what Nolan wants to do, or this is what I want to do in the end, and then responding to that. So yeah, it's a big one basically, and obviously, or simplification of that is that Nolan's brain only uses the cursor, so it only replaces the mouse basically, and me using my hand basically, that motor control again to coming to those journeys. Think about it this way: it's another way to interact with a cursor for now. Cool. Do let me know what you think about it, if you have any challenges or thoughts in the chat, because this is a big subject and we are just entering the good stuff. I thought I would include some of the history because again, I mentioned it and I'm just gonna breeze through it, but the actual BCI as a field of research, as a lot of disciplines involved and a lot of other takes, it's been around for a good 100 of years, a century, which is massive. It started with the actual, you might have heard about Hans Berger's, who invented the EEGs, and this is a massive thing for for actual health industry. When that kind of like as some people invent, as they make research papers, like let's say Elon Musk just published with Neuralink another paper now. Chances are someone tomorrow is going to take that research paper and build upon it. So that knowledge kind of permeated and transferred. I'm not going to show you this snapshot, which is Alvin Lucier, who is basically a music performer. He was the first one, or notably so, the first one to use EEG to interact with the specific music processing, the percussion basically machine to make music. Let me actually maybe quickly pull it up to see if that works. Don't really like opening Facebook much, but let's just do it justice. I mean, it's question, music is one thing. It's obviously ability to play different things with your brain depending on what you think and how you think ultimately, in terms of the waves and frequencies. So there's obviously percussion. I don't know if you can hear it, by the way, so sorry if you can't hear it. But basically, Alvin here used simple EEG machine, and based off the brain frequencies or what it could capture, it would play different percussion instruments. Now, this is interesting, and why I wanted to bring this up, or these examples, or why I wanted to show this specific case, was because it kind of shows that you, as a user of a BCI, you need to know what you're doing, or you need to basically adapt to the extent. You need to think about certain things. For example, certain patients who use, or who the EEG is used for, they're shown, again, lights or different frequencies of light, because that's what primes their brain and that's what stimulates the specific frequency so that they could be captured and then, for that information to be displayed on a doctor's screen. So exactly the same way as Nolan would use, or Alvin would have used his invasive BCI, it basically requires the user to do enough repetitions for it to be trained and for that information to be, again, protocoled enough and processed enough and then crunched to make some sort of action and feedback back to the user. And then in 1973, 1977, there was a lot of research. Jacques Vidal, maybe I'm mispronouncing his name, but he basically coined the term BCI, did a lot of the different I guess, tests and experiments. And one of the first papers for non-invasive BCI was part of his research. And he was the one experimenting with the first cursor-like graphical object on a computer screen, which is massive because that's exactly what paved those next steps for the actual Neuralink. And in 1988, Wazynovsky used the actual non-invasive EEG control of a physical object and robot control. So we used the same machinery to move a specific physical robot. And the simple interaction there was, it was quite simple. For example, if the eyes were closed, the robot would move. If the eyes were open, the robot would stop, and so forth. So it was just that to kind of prove the way that you can actually control something which is extensive or peripheral to you through simple thinking or through simple visual cortex control through eyes, let's say, which again, eyes are part of the brain. So it's super fascinating. And then you have the bidirectional adaptive BCIs, which were, computerized and kind of paving that way. And BrainGate developed the first brain-controlled computer, which was invasive. And that's, I guess, a precursor to Neuralink. Let me see. I don't know if I can open it now.
Matthew Nagel was paralyzed from the neck down after being stabbed several years ago, but technology gave him hope. He was one of 4 testing BrainGate, a new technology where a chip is implanted in the brain that picks up electrical impulses. A computer then interprets those impulses as actions. The chip is implanted just beneath the patient's skull and is only a few millimeters square.
So you saw that the single unit, multi-unit, the electrode arrays, this is exactly it. It's the technology of the invasive BCIs.
Here's Matthew playing a computer game. He's not using a mouse or a joystick, rather he's thinking of where to move the paddle. All thoughts are electrical impulses, and after extensive research and testing, a computer has been trained to decode those impulses and create the corresponding actions.
Yeah, so this is perfect example of what we discussed and probably answers Alien's question of like, how do you differentiate? It doesn't really differentiate. You just train enough and do enough repetitions as a user. Now, I wanted to bring this up too, because the BrainGate was, it was done again, 1980, am we getting the actual year? No, it was done in 2004, so 20 years ago, 2 decades ago. Now, this is super invasive because, as you can see, the actual electrodes still stick out from the head. So it obviously restricts the actual user. You still need even more touch points, more of those interfaces around you to kind of maintain and be careful of. So that's how the big of the delta is between this state and what the Neuralink did. And I think it's a fascinating case because you just realize exactly what the steps were to actually get to this in the last century. Now, in around 2017, again, Neuralink coins the BMIS, which I mentioned before, but BMIS is the brain-machine interfaces. Don't ask me what's the difference. I feel like it's mostly marketing, but as with every milestone in this timeline, there were a lot of coining of the terms, which is rightful to do because you want to have some sort of basis to kick off on to do the next phase. You want to know exactly at what state and what are you talking about. You might have seen the actual animal trials before the FDA approval for the actual Neuralink for human trials, where, let me see if I can bring it up, easier to talk and show instead of just talking. But this was the video which was massive, a few years ago, where the actual monkey was using the screen. And this is a big one, because you have to also consider that with the primates, you have to train them enough to understand what they see or what the screen is. You can't obviously explain to them what it is or how to interact with it, but you need to encourage and you need to incentivize their behavior so they know exactly that if they look towards that freaking square on a screen which is moving, which to us is a paddle, obviously is a metaphor, to them it doesn't mean anything. They're gonna get incentive and they're gonna get rewarded. And as such, you basically have different training methods which you have to do so much harder to train some sort of primate or mammal, through Skinner's conditioning methods, let's say, or things of that nature, which is well documented. But that psychology of training a mammal to do something else through reward or some sort of desensitivization of different things is a massive hurdle too. And this is also what's very impressive. It then blew my mind. Like, I kind of knew, okay, this is at the pivotal point where at any moment we're going to hear about humans doing so, because if a primate can use this with no issues,
and he's playing entirely of his own volition.
it just would be, no issues for a human being.
It's not magic. The reason Neuralink works is because it's recording and decoding electrical.
Yeah, a short video at that, but it's fascinating because after that, there were just a couple of years. Obviously, the technology improved a lot too, and it's still improving, it's still being developed. But they got the FDA approval, they actually made it. And let me just show you a few demos of the actual things, because it's fascinating. So this is actual Neuralink user playing the Mario Kart, just with their thinking. Just the same way as that primate used the Pong, the old school Pong machine, or that game. The same way you can use and control the Mario Kart. And I think the bigger demo and the bigger fascinating kind of demo to that is this one.
Live here. Hello world, how's it going out there? My name is Bliss, and I'm an engineer at Neuralink. And I'd like to introduce you to the first ever user of the Neuralink device. And I think you're my only telekinetic friend that I have.
I'm gonna skim through,
while
just
he's
so
introducing
we...
himself, let me just flip the camera on so you can see what Nolan's been doing.
Yeah.
Let me come over here. Do you want to explain a little bit what's going on here?
Yeah, so I love playing chess, and so this is one of the things that y'all have enabled me to do, something that I wasn't able to really do much the last few years, especially not like this. I had to use like a mouse stick and stuff, but now it's all being done with my brain. If y'all can see the cursor moving around the screen, that's all me, y'all. It's pretty cool, huh?
Actually, can you pause the song just for the audio coming through?
So I don't know if you can tell in the actual video, but Nolan is using a cursor to interact with a simple chess app, or quote-unquote simple chess app. It's the same way as I'm interacting with this video. You can't even see my cursor on a live stream, I can tell, but it's the same way. Again, just motor control is missing. But it's fascinating. Oh, let me see if this is actually a better angle.
My right hand, left, right, forward, back to. And from there, I think it just became intuitive for me to start imagining the cursor moving. Basically, it was like using the force on a cursor, and I could get it to move wherever I wanted. Just stare somewhere in the screen, and it would move where I wanted it to, which was such a wild experience.
This guy wants to know if you feel like a wizard.
Yeah, right.
Amazing.
It's
You see that the mind blown type of the actual user is I mean, my mind is blown, but I can just imagine what they feel and how their mind exploded with the possibilities of what they are now able to do. Because again, a person is quadriplegic, right? So it's the limited motions, the motor controls are limited below the neck, and this just allows them to maybe even do work, and maybe at the minimum do play games or contribute to the research of Neuralink, which is exactly what we did. Obviously, look at your own leisure, because there are so many videos of those demos. There's also a video I want to talk to you in a minute about of kind of walking through the onboarding and how the person calibrates it and how they interact with the rest of the apps. But before that, some of the summaries of this actual implant, which I think is quite interesting, and maybe it's more technical aspects of that, but there's 3,000 electrodes basically for Neuralink's implant. It uses Bluetooth technology, and what I could find is that it's charged remotely, or not remotely, wirelessly would be a better term, which is quite interesting. I didn't even think about the actual implant needing energy, ultimately, because that's even more impressive, because Neuralink itself is a size of a coin. Obviously, it has the wires which go behind the person's ear where the actual wireless charging is happening. So it doesn't happen literally above the actual implant area. Now, the first-hand experience of Nolans. I think this is the most important thing for us to go into today. Let me see if I can pull it up quick.
Or like finger spelling, like sign language, which is pretty cool. Then I have this research tab, which is the link.
So Nolan as a Neuralink user, and this you can imagine, let's say in the future could be you, if you have some sort of cyberware or some sort of other futuristic technology implanted in your brain. Nolan always has to calibrate his Neuralink implant. They have to always go on this app which Neuralink produced. And again, this is a massive, again, touch point. If you as a designer think, oh, I can design for this, yes, you can, because there's going to be tools. Doesn't matter who you are. You could just be a product designer focusing on UI. So many use cases and so much you could help out Nolan for him to calibrate map research and things of that, or game basically with their machines.
App is how I am able to control this computer. Everything is through this. This is where I do all of the daily tasks that I do with the team. This is the hub for everything. I imagine this is how, for the future, when implants are in more people, or just with me, I guess, this Link app will be put on other devices, say phones or other things. Everyone would have this app, and it would make those devices compatible with the Neuralink. So it's pretty cool. So right here, these are like all the devices that this is connected to, that the Neuralink is connected to. This is Eve, my implant, which I named.
And here you can see exactly that the actual user, and when I say user, I'm obviously referring to Nolan, but you can see clear indicator that the actual implant is connected. So there is always a feedback for them to know that, everything is good. You can also see the battery life, which obviously Nolan is responsible for as a user to charge in their day, in their journey, so that it's always up. I think the personalization here is also pretty cool, because obviously even Nolan said themselves that he did name it Eve, which kind of sparks that ownership I guess, incentive for him to take care of it, to not drop the research, to actually train on it, calibrate it, basically use it daily, because it's his Eve implant. Basically, it belongs to him. It's part of him. It kind of has to be like his. I'm gonna use a joke here, but his basically Tamagotchi, right? Like the actual small implant which he has to take care of. And I think that probably is not done consciously by Neuralink team, but if I would be a UX designer on there, that's my thinking why I would have added that. So kudos to the actual product team from Neuralink, because they obviously maybe inadvertently added it. They maybe didn't even know about it.
Other two things are the chargers for my implant. This is the calibrate section.
This is very important. This is what I'm talking about, because every time Nolan has to use it, he has to go and calibrate the Neuralink. Obviously, because of a lot of physical factors, the brain waves change, the signals change. There is a massive scarification as well in the brain, because it's healing. It's basically trying to obviously reject the things which don't belong there. There's so many kind of like things which we need to consider.
Is something that I do in order to give me control of the cursor. Basically, it's the process of the Link app learning what my brain signals, like learning to map my brain signals and like keyboard control. So I would go into the calibration, I would do that, and then I would get the control that I have right now with the cursor. That started out, basically version 1 was a lot different than where it's at now.
That's really important too, because that's again pinpointing that point of like, he knows that he's part of a research team and every version is improving with him. In fact, I think in this video shortly you're going to see that they created some apps specifically for his interactions, which we're obviously going to use for people going forward. So because Nolan is number one test subject or participant, more people who are going to come in obviously going to use the tools which they designed for Nolan. And what did we use? Obviously, we did some agile product design and development, a lot of user research, consistent engagement with the actual person, with a human being, to understand what we need, not just what we want, but what we need, and then giving them applets and add-ons and so forth. And by the way, do leave a comments in the chat. It helps me to also dig deeper into a specific subject so I don't gloss it over. Do let me know your thoughts, challenges, things of that nature, because this is very fascinating subject.
Been a lot of trial and error, but it's been a pretty cool learning process. And at this point, I'm able to do it basically completely on my own. Before, I would be doing it in sessions with the Neuralink people, and they would have to run the whole thing, and we tried out 100 different ways of doing it. This is not, I would say, the best model that I've ever had. The model is whatever the cursor control is that I have when I come out. It will update throughout the process, and it'll be a lot better with more time.
That's that training and onboarding and learning. So, and I think it's great that he kind of mentions it, so he doesn't just gloss over it. Hey, I got that implant in 6 hours and I was capable to do all of this. Like, he obviously stresses it enough. And I'm putting the user researcher's hat and kind of taking it in. Like, if I would have been doing interview right now, I would be making so many notes that, okay, this was like a big demand for the user. He literally spent months daily trying to work with it to change that model. As he mentioned, this is not a version 1 of it.
And the longer I stay in the calibration, generally the better it'll become. So I can stay in there for 30 minutes, an hour or more if I wanted to. And hopefully the cursor control would get even better. I also can do what we call like body mapping. This one is like right arm pushes. So you'll see like a right arm on screen, and I will follow the visual to map what my intention is, and they tell me what they want me to do basically, and I'm doing it. And so they know what certain neurons are like firing and being mapped to certain parts of, like certain intentions, parts of my brain. That's pretty cool. I do that a lot.
Yeah, and you see, this is kind of describing exactly how he would use daily. So he has to again calibrate, use that app. One thing which is quite interesting is this thing, which is basically
They are
Neuralink created games to help calibrate but also train the actual users. Like Nolan here, let's say, is using this WebGrid game to over time develop the actual skills for the right neurons to be connected. Like basically he's using his brain to train the actual BCI or the actual Neuralink AI through his chip implant. And he knows it well. So he says he spends, I think, a few hours a day doing that.
surprised at how much I sit around and do this just on my own. It is addicting. This number over here will climb as I get more targets for every minute. This is basically, see the red when I miss. This is basically how we test if the model is very good. This number goes up basically as high as we want it to, but I think I use like a 35 is like the highest we go. Anything over than that isn't super great. The targets are pretty small.
UX, right? So even in this game, I guess he recognizes that if the grid is too big and there are way too many small touches, which I think here is probably like a similar to touchscreen grid, like it's 25 by 25, which is roughly, I think, corresponds to the usability principles and accessibility principles and guidelines from WCAG, right? But even then, because he's using his brain to move the cursor, ultimately the area of a touch has to be big enough, because otherwise he might miss. And that's because if we go back to the original point where I said, or where I shared, and his quote too, is that sometimes it moves even before he decides to move, and intentionally so, because you don't have to go through those motor control loops and latency and everything in between. It's kind of like he thinks just, I should move there, and it's already there, basically. Adriana's comment, crazy turn for humans and UX. My harsh prediction is that AI will not erase humans, but instead will combine with them. This is very scary and exciting. I do agree, like absolutely. I think the combination of the technologies is what the future is like. Just like it has been before, like we didn't have so many diverse channels and technology stacks. Now we do, but AI is not just AI. There is so many flavors of AI. But here it's like a rightful application because that person actually needs it. Like the Nolan does need AI badly. He doesn't need a chat GPT. He needs AI which understands what he tries to do and trains off those trials and errors and those historical data pings, and then allows him to, calibrate his things and kind of play this game, let's say. And then for you actually see a great future since all the interactions are changing. Yeah, definitely. But you can immediately see that there's going to be a big demand, even if maybe you're just a product designer, just quote unquote. I mean, if you're focusing just on apps or digital products ahead of you, still there's going to be so many use cases where your skills are required. It might be hardware, it could be digital, it could be software, it could be all in between. It could be omni-channel of a lot of elements and a lot of factors and touch points. This is exactly what it comes to my mind. And I'm kind of overreaching already, but I think Adriana called out really good point that it should excite you, because your information architecture skills, your research skills, the empathy, understanding user psychology, how do you research with a person like Nolan, how do you express and ideate of how to solve those tiny problems for him is a massive one. Massive opportunities, basically.
There's a numerical like progress to be made in all of this. It's super fun to just keep testing myself, to keep pushing. And yeah, I think 8 is not the best I can do. I think that is just where I'm at right now on devices. So right now we were using it to play Mario Kart. When I played Mario Kart in the video that I'm
As you can see, we're basically adding different applets for him, and I don't want to go deep into this because you kind of know exactly the extent. If he can move the cursor and activate it, he can basically do everything you could do on your phone with your thumb. It's exactly the same thing. Or if your mouse on a laptop, you could get a virtual keyboard and then basically work. And I think other games are like the Snake game too, and things he demos. You can look into that as well. He's learning Japanese as well. So he's using simple web apps and interfaces available to absolutely everyone, but he's able to interact with that just by thinking. Chess, again. Oh, and I think this is a really good thing to call out. Just about the customization and personalization of experience. So Neuralink team,
I think he's gonna kick my butt, honestly.
helped him calibrate a few things.
And tear it apart. They already have been. I know that I'm not very good. No need to tell me twice. Let's see what else. I don't know if you guys can tell. My cursor control is not as fast as I would want it to be. It's kind of not as smooth as I would want it to be. So there are a couple things I can do. One is this mixer, which they've given me control of. At the beginning, I would basically have to ask them for all sorts of help. If something was wrong, I could have to wait around or just deal with it or just not use it at all. Now I have this little mixer, and what this does is gives me a bit more control over how this cursor interfaces. So the gain right here is basically speed. So I'm at 2.4 right now. If I keep going up, this cursor is just going to get faster and faster, which I am a fan of. It'll help me move across the screen a lot easier. The friction down there at the bottom is, well, it's exactly what it sounds like. It's friction. Keeps it slower, maybe keeps me over targets a bit better. And so I'll turn that down because I feel like it's slowing me down a little. There we go. Okay, this moves a bit better now. Yeah.
And obviously this personalization, again, an ability for him to just self-serve and customize his experience is massive, because different games, obviously, like the tiny grid requires more friction and precision to adapt, right? Or adjust the gain. If a strategy game, which I think there is a demo too, you obviously want more spatial ability to kind of, browse through basically the landscape or to quickly shift the things. You need that responsiveness. And I think other bits which he describes is really his experience of using it. But obviously, he's a person who's controlling his OBS right now. The software I'm using He's the one who's basically streaming and setting this up. He doesn't have to have anyone else, as long as he calibrates his cursor and he calibrates the technology with his responses and thinking. He's able to basically do everything anyone else would be able to do. He would be able to stream like I'm streaming now. And it took me so long to set it up physically. Every time it does, because there are so many inputs. But that's absolutely amazing, because if he thinks, he can just jump into it and do it. Do let me know your thoughts, because to me this is mind-blowing. This is absolutely amazing. Like, and not just, I guess, you know, I'm saying just, not justly, but not just from Nolan's perspective and his life becoming so much more better. Like, he can do so much more, like, inarguable. But everyone else's life can become the same way. Because at some point, I think Nolan, in that podcast, he mentioned that it could take like 15 or 20 years for this to be commercialized. And his trial is also limited because of those quote unquote hardware issues. But at some point, it's going to be all commercial. Why I wanted to call this out just to showcase is that this is very important from UX strategy perspective and UX thinking, design thinking, the human psychology and experience perspective. But what I noticed, and this is almost that 100-year zoom out thing, is that every single interaction, whoever it is, it could be that primate, the monkey using the Pong screen, or Nolan using this, you know, his demo screens. There is a massive learning phase which is required of the user. So that companies like Neuralink or anyone like, back in the day of EEGs, they're required for people to do some sort of onboarding and then continually engage with the actual implant and the interface to calibrate and develop it. He himself said there are so many versions of this model. There is so much human-computer interaction calibration, the learning of what BCI can do and can do to what extent, the ability for the team to kind of develop extra things because Nolan couldn't do. But he's basically a test subject number one, besides the BrainGate example I shown before from 20 years ago. As Alien says on the chat, speechless. Me too. Besides sharing what this is, as a result, it's absolutely amazing. You can't kind of say anything else. But as you go through that, at some point, all of this becomes so operational. Let's say Nolan right now is this operational phase where he can do a lot and he knows how to do it. He knows the limits, the extent. Every day he can, do that research or help out researchers at Neuralink and do what he wants to do, either play games or train his brain or chat with his friends. I didn't show in a demo, but he's able to pull up the software keyboard just like you would on accessibility controls on your machine and type letter by letter with his brain, basically by thinking. So it's another way to interact. He's basically much more connected with his surroundings and able to do what he wants to do. But that obviously is all, happy and everything else. There is obviously another side to the coin, which is that there is a effective hardware decline phase, or something I would call effective hardware decline phase. But hardware, not that Neuralink is becoming worse over time, it's that the biology is limiting this. And this is going to be a massive challenge for anyone. I know it might not be UX challenge, or it seems like it's not, but it is, because you as a UXer or human experience designer of sorts or producer, you need to consider that there is a half-life to this. And at some point that half-life is reached, and the rest, the half-life basically, is going to be a slow decline. And from the podcast of Nolan, he feels like he reached that. He reached the peak of the experience, and there is a decline in the feedback, in the, how it works. It basically gradually becomes worse and worse. Granted, the AI can sense that. You can still train and calibrate AI, but AI then, it's just software. Like if the hardware declines and let's say your brain gets scarified and neurons get scarified, like there is less connection. And I'm, in layman's terms describing this, but basically your brain just heals itself over And it's harder and harder to get those signals for AI to do something about it. And it doesn't matter how much you train on AI, it's like a continuous battle, for survival ultimately to do this. So Nolan, and I'm, talking for him here because he's not here, but I think he described, and paraphrasing that from that podcast, that this is a limited trial. He knows that he's the first one, and he knows that at some point the trial is going to end and someone else is going to take on the baton and they're going to get a better implant and so forth, until it reaches the point where it could be commercialized enough or being more open, where the actual effective hardware decline phase is controlled over, or it's much longer. Again, it's been like less than a year, I think, of this experience, but that's what it took to get to this point. And obviously the decline is happening. So it's a bit sad, obviously, with all the wins and all the progress and achievements, it's a bit sad that it's not permanent. But it's, again, step number one in so many different steps to come. Do let me know what you think about it. I'm almost done. There is a few bits which I want to talk to you about, which is the future of BCI and what it could look like once we reach so many different touch points from UX perspective. What could it mean for us from emerging tech perspective? So as all of this is being progressed, and again, the history of 100 years or so of development in these different non-invasive and invasive methods, there's a lot of signals out there. If you're in a gaming community or you're adjacent to it, you might have heard that Valve co-founder, Gabe Newell, who is a person behind the games like Half-Life, Counter-Strike, and many others which were cult and still are cult. You might have heard of it, at least of those. He's part of a founding board from another brain interface firm. I think it's called something to do with a star. I don't remember what exactly it is, but you can quickly search and find it. There is a lot of startups budding up right now, basically using the same method, same technology, same findings. And as Neuralink and Elon Musk are publishing those papers, that knowledge is being used as a stepping stone to build up and do better technologies. There's obviously some older technology and startups like Muse. Let's see, something I heard like a decade ago, which uses, again, non-invasive EEG band to train your brain to focus, meaning it observes what you think or how you think, to what extent, and it guides you to relax and be more mindful, things of that nature. So these are already happening. And this is a BCI 101. You could buy it right now and use that. And I'm sure if they have some sort of API or some other methods, you could maybe expand and build upon if you have a technical expertise. But there's a lot of hardware startups and startups which use all those different findings to kind of create that. And I think because of generative AI, we don't hear much about this, or at least I don't hear much about it personally, but there is massive funding coming into these things, especially as these demos are so mind-blowing. For example, Neuralink raised $6 million to create the everyday brain computer interface, and their everyday computer interface is headphones. They use the same EEG technology as the Muse headband, and they allow you to control the music, and your auditory sensors adapt, basically. Another BCI example. I know that Apple is also patented something to do with EEG, meaning they're going to be able to read your brain waves, your brain activity, and do something with it. Unclear what yet. Maybe it's going to be part of a health app. Maybe it's going to be something part of some other experiences, but it's a massive boost to overall ability to do something with that. So the technology persists, and there are so many applications there, and it's already part of a consumer tech. It just, I don't think people are aware that, okay, this is actually BCI, or this is actually just non-invasive Neuralink in a way. It's just that the and use case is different. Same for, let's say, Snap. The former, what's it called? Snap Inc. Snapchat. Sorry, the former Snapchat, Snap Inc. A bigger group of companies. They acquired, let's say, the headband maker NextMind, exactly the same EEG too. Various, let's say, Austrian Fire Brigade is using EEG as well to train their, firemen to be more mindful and to adapt. And there's a lot of cases. I'm not going to go into it because I'm not going to do it justice. But the EEG as non-invasive is like the low-hanging fruit of BCIs because it doesn't require no human trials, implantation is super safe. It's just reading of the basically signals ultimately and doing something with it. Kernel Flow is a premium multimodal headset, another headset. Same for, let's say, Axon R, which basically uses EEG and AR technology, which I think Alien in the chat kind of noted it down before what would happen with XR. This is it. So let's say if Apple, now that we have a patent for their earbuds having EEG reading and ability to scan and detect that, they could combine it with their, the actual Apple devices for AR, maybe the next generation, maybe the old generation of it, but they basically can create better experiences sensing exactly what the person is thinking. Now, the EEGs are extremely inaccurate in terms of you controlling something because it's not about that. It's a general wave activity, and you could obviously train yourself and use it enough to maybe relax, to be mindful, to maybe use something else, or maybe trigger some sort of big theme like, hey, open Spotify means me being super agitated or thinking about the elephant, something along those lines. But basically, it's quite inaccurate. It's not the same as, let's say, the brain activity capture with Neuralink or some sort of brain gate, the invasive type of technology. And of course, other bits. There are other bits which, let's say, are partial. So you're going to notice there are startups budding up which basically have detectors on your wrist. This is not bad, but something along those lines, which, let's say, use buzzing and also some sort of other detectors, which are sort of like, you could argue it's between BCI and not so much, because it actually is more about haptic feedback. But that is obviously processed by your brain, XYZ. You could kind of, untangle the thread here. So there's so many use cases and there's so many more. This is just quick capture from what I could find immediately to illustrate it. But damn, this is going to be the future, and it's already here. It's just that it's not that widely advertised. And again, the boundary between non-invasive and that cyberware which is implanted is massive. Cool. Let me see what the comments are like. We can do so much more. As you mentioned, I hope the attention goes towards what it can help. Love the science, AI application, and OES biotech will become a big thing. Yeah, definitely. But it's just becoming much more consumer focused to me, I think. Because likewise, Neuralink is focused on health tech and improving someone's life. But let's be honest, there's obviously commercial thinking beside it. Even if, you on an ethical realm, you want to improve someone's life and make things accessible, it's a stepping stone, because eventually Neuralink in the next 50 years is likely going to be implanting that same thing on everyone, and there's going to be so many competitors using the same for any quote-unquote capable or able people, or not necessarily someone who's less able, on accessibility spectrum. Yeah, and as I said, this was the journey which I started with this stream, and I want to end it with that, because again, to do anything, let's say right now, using the BCI control, you still plan, execute, and you observe. You skip a few steps from motor control, you do them much, much faster as a user. But if you converge it with voice assistance, super speedy, again, some of these signals pictured here are already here, but think about version 10 of them, like always connectedness, AR headsets, AR technology, holographic technology as well, which is already coming. Quantum computing for processing power, again, safe cyberware implantation, and them lasting long enough for that hardware degradation to not happen. Much more safer and more minimal in the intervention side implants as well, which would be smaller. Again, less of your body being sorry, let me paraphrase it. Your body not rejecting it as fast as well. So a lot of material science could come in. Basically from everything we're already doing with generative AI to material science and hardware, all the science has to converge for this to be commercial and much better. And I think it's going to happen. It's unavoidable. Like at some point, all of this is going to come into one single point, and that new Neuralink might be, I don't know, a pill you swallow, which somehow through nanobots crawl up through arteries into your brain and sticks there. You know, like a lot of the things sounds like sci-fi in future, but that's what happened when, let's say, back in the day when Hans Berger invented the EEG. That's how he probably thought about this, that it's, you know, it's sci-fi. Same for Alvin Lissier, who created music with his brain. It was sci-fi for everyone, right? But like if they would see it what it is now, again, their mind would be absolutely blown away. It's that crazy. And, you know, it's not too crazy to think what it could be, and we should be thinking. So maybe a key takeaway from this for everyone is also to think, damn, what could the future look like? Because it's boundless. It's absolutely boundless. And if you can project it and picture it and visualize it, maybe create a storyboard or prototype, vision type it, you're likely to land somewhere close enough when the future actually comes, because it's going to pave that way. I want to end a few things. So let's say if these, and this is going to be a common exercise, so do let me know in the chat if you think the same way or challenge me or you want to build on. But if we can converge on all that technology, that journey we started with could look very different. You no longer need to work at a desk. You can basically work anywhere. You know, well, you still probably want to decide on listening to the music. You no longer need to look at the screen or find the trigger, because all you have to do is think. All you have to do is really think and work with AI. You know, like you no longer need to look for, again, triggers. You no longer need to look for toggle, because you might just have a voice assistant which is done right, maybe something like one of those AI pins, the humane AI pin, but done right. So all it is really for you as a user in the journey. You're going to decide that you want to listen to the music, think of a song you want. You obviously picture maybe Spotify interface, you hear it. It's as simple as that, because you did it long enough with actual AI for it to analyze and detect that, okay, this is what, I don't know, Adriana or Alien or everyone else who's watching this basically decided for it to do. Over time, you have enough historical data, enough signals to learn from it and say, this is what good looks like, and therefore the actual, you know, experience happens. So it's going to become much more simpler. And this is, again, 20 years, maybe even more, because, again, human trials and technology has to progress. We have to understand how to do it safely, ethically, and also avoid those things like effective hardware decline, because, again, it's a temporary thing right now. It's not like that implant can stay there. It's not a heart ticker you implant, or it's not, you know, some other implants which could be safely monitored and, you know, adjusted or changed over time. Like there is a lot of risk involved in this. So as such, I feel like we're on a journey, and if we zoom out, all the different things as a UX designers we can start preparing for. That's why I wanted to do this live stream and kind of share with you these exciting themes. Again, make sure to look at those demos, make sure to kind of research a bit more, but this is coming. It's like, I can bet whoever is watching, at least one of you from, you know, those few, you are going to be involved in this if you stick with UX to some extent. Maybe you're going to make calibration apps. Maybe you're going to be user researcher interacting with that patient or, you know, trial subject, whoever that is, or maybe you're going to do something else. Maybe you're going to need to figure out how to create voice experiences, auditory experiences, or use AR headsets and things of that nature. It's going to be you. You know, myself, if I'm still doing UX in the next decade, it's going to be bread and butter. So I'm preparing, and that's what I wanted to do this live stream for. This question is out of a topic. As a graduating UX design student, I'm debating between pursuing product design roles or specializing in product design in XR design. Do you have any advice on this? I think it depends how bad do you want it, as in terms of, do you really want to be XR designer bad enough? Because if you do, then go for it. But also consider like how bad do you want it in terms of you being able to support yourself? Because if you zoom out, still majority of the projects are going to involve other things. So personally, what I would do, and don't take my word for it, this is just a perspective, discard if it doesn't make sense. But I would do both. You can still do projects on a site which are in XR, or just general projects on enterprise tools or customer experience apps or some sort of other channels. Ideally, if I would restart my career, I would be looking to capture as many of these things you see on my screen as possible. And these are general themes, and I cannot describe you specifically what. For example, as a senior back in the day, I created myself, I coded it, like a simple Alexa skill, which was that voice app, basically activated app with research and product design, researching stuff like that. It's like basically doing it myself, because I knew that this is something which I need to have in my skill set. As such, as a product designer, I would advise you not just think like, oh, I'm just going to do one project and then I'm sorted. No, you just think about this as like, okay, I'm going to do project A and then project B and then project C, and then I'm going to adjust my course. If the market doesn't need XR or it needs something else new, which likely not going to happen, it's still going to need some of that, I'm going to adjust it. So don't fixate on something which is going to disqualify from something else. And as long as you move and do, not just think, stop thinking, start doing now, like you're going to be okay, basically. So keep on, snowballing your knowledge, your experience, keep on doing your projects, documenting them, making case studies, and then adjust as you go, day by day, signal by signal. Now that you know about brain-computer interfaces, think about like, what could it be? Like, what could I do now for this specific thing? Maybe you could even do a challenge to redesign the brain-computer interface calibration flow using XR. Or maybe think about how Nolan could use XR in his day-to-day scenarios instead of a screen, and how that calibration could look like by eye tracking or something like that. That's a big hypothesis, but it's something you could explore now and capture it. Granted, it might not resonate with every employer because they're not doing it yet. But if you have that, imagine in the next 5 years you're doing this interview, and the hiring manager is like, oh, we're thinking about emerging tech and we're exploring AR, and we're also, partnering up with this Gabe Newell's newest startup in gaming who does the, brain-computer interface. And you're like, hey, I did this project back in the day, and this is what I did. This is what I figured out. These are the outcomes. I have a case study. Bam. That's how it works, because the more senior you get, the more portfolio cases you have, the more picky you can be, the more of the kind of like a passport approach you can do, where you're pulling it out and saying, yeah, I can do this. I'm here for it, because, you just have that experience. But yeah. Thanks so much for everyone tuning in. There is so much more in this. Do your research as per usual. I hope you enjoyed this. Do let me know what you thought about this stream. Leave a comment after the stream is done. You can watch the playback. But, I appreciate each one of you. Thank you so much for comments, because it helped me a lot to go through this. There's a lot here, but I hope you enjoyed it. And on that note, have a good weekend.